Hi and welcome to another Unity from Scratch tutorial. This is for the basic set of tutorials and also for the mobile set of tutorials. Now I'm about to launch into a series of other tutorials looking at how to use the gyroscope and accelerometer in your mobile device. And so a little bit of background information on the axis system in 3D space is very relevant. This is also relevant when you want to make your own player character and have them move around in the scene in a natural manner. Now, the three-dimensional axis system and the way that you move these axes around really confuse a lot of people, including me, okay? I don't know why. We live in 3D space, but for some reason we get completely confused when we start moving, or I should say rotating things around in 3D virtual space. Anyway, let's have a little look at what's actually happening. So what I've done is to make up a pretty dodgy looking character, which is a cube and a sphere on top. And I've made it have its own axis system just by using some cylinders that I've colored. All right, so you can see those here. And for each axis, I've actually used 3D text so that we can see which one we're talking about. Now, the application here also has a text box up in the top corner, which I'll print some information into later on. So this is nothing you couldn't just do up yourself. It's just the cube, there's a sphere attached, the cylinders, and the axes text on it there. Now what we're going to do is rotate this cube around using the X, Y, and Z keys as well as the arrow keys. So I'll show you the code I've put on here. It's called Rotate Cube with a capital R and a capital C. And if we just go in here and have a look. So first of all, you'll notice we've added this Unity Engine.ui at the top, which allows us to take that text area into the code in order to put some values into it later on in the code. Start function isn't being used, so you don't really need that. In the update, you'll see that there's three sections, one for getting the Y key, one for getting the X key, and one for getting the Z key. And when these are pressed, they rotate around the respective axes. Okay, so you can see that pressing Y will rotate around the Y axis, which is 0, 1, 0. Pressing X will rotate around the X axis, which is 1, 0, 0. And for the Z, it's 0, 0, 1. Further down, I've also got some code that's going to rotate around the Y-axis when you use the left and right arrow keys with the horizontal get axis, and will rotate around the X with the vertical get axis. So these are using the arrow keys to turn your character around left to right and to make you look up and down, basically. So I've just thrown in the nose so we can see the effects later on. And then finally, we're actually using that text area that's on the screen to print out the values for the X axis, the Y axis, and the Z axis. And we're using the Euler angle values. Now, in high school, we're taught about Euler angles, and these are the values for X, Y, and Z based on how the axes are rotated. But for some reason, when we try and rotate axes around in our own minds and using our own sort of logic, the whole system kind of breaks down because we forget when we rotate around one axis where the other axes are actually positioned in 3D space. And therefore, the whole thing kind of goes a little haywire and you're left thinking, what have I done wrong? But you probably haven't done anything wrong. It's just the way it really works. So let's have a little look at this. So if I press play and I use the Y, you'll see the character rotates around the Y. And if I use the X, we'll rotate around the X, which is this way. So we should bend forward like that and keep going around there. And then if we rotate around the Z axis, we will rotate around the Z axis. Now, that seems all quite logical until we want to use our character as a game character. So I'll use the arrow keys now. When I use left and right, I turn my character around like that. And then I want my character to look up and down, I would use the up and down keys like that. But what happens when you're not standing upright and you go to look left and right? Look what happens to the x-axis. So the x-axis no longer turns around the horizontal like this. It's turning around based on where it is, because when we move the y-axis, we're also moving the z and the x. And so then when we try and rotate in that direction, our character sign kind of goes the wrong way. So unless the character is standing dead upright, turning around on the spot becomes quite difficult. And the same thing for bending over. Unless you're standing perfectly upright, which I now can't seem to get my keys to do that because the system's become confused, you'll find it quite difficult to actually bend forward into a bow for your character if your angles have become all messed up. So just say at this point here, we can bend up and down. But then when we try to turn around on the spot, we're actually turning around the y-axis, which is now not going straight up. So it makes your character look quite odd if you try and do that. And it's even worse if you slap a camera on it and you're using a first person and you're trying to move around. The environment does not seem to line up with the way your brain thinks you should be seeing it. So how can we fix this? Well, you can do things like rotating around a particular axis. By default, when we use rotate, we're saying that we want to rotate around a certain axis that belongs to the character. So you've got your Y, you've got your X, and you've got your Z axis. But we can also rotate around axes that are in the world. If, for example, we're bowing like this by rotating around the X axis, and then we actually wanted to turn on the spot around a perfect up and down axis, then we could do that. And the same thing in reverse is that we could be turning around the y-axis, but then we want to bend over and only be bending over the horizontal, as though a perfectly horizontal line was going through the middle of our character. By changing the code, and I've created a new version called Rotate Cube World, we can, instead of rotating around the axes of our character, rotate around world-based axes. And I've done that by changing these two lines just down here. And you'll see that the rotate for our horizontal axis, which turns us around standing up on the spot, hasn't changed. So it's still going to rotate around the y-axis of our character, but the rotate for bending forward and back or taking a bow is now going to take place by bending the character over a horizontal beam, and we can specify that axis as vector3.left. So this is a perfectly horizontal vector in the world, and then we use again the vertical get axis value, which I found at this point you need to multiply by 0.1f, otherwise you're going extremely fast. So let's have a look at the difference this actually creates. Let's go back into here. Now, if I turn on the spot, nothing different is going to happen. But when I bow forward, I'm bowing forward over the horizontal. Okay, so notice that when I bow forward, I'm bowing forward over something like this here, not the x-axis as I was bowing over before. So if I turn around and have the x-axis poking out in that direction, I'm now forward and back. And it doesn't matter where I am in the y-axis rotation, my bowing forward and back is always going to be over a horizontal. Now, you might say, why don't I do that over the y-axis as well? Well, that creates another sort of problem. If I go back into that code, and let's just change that around, and I'll show you what happens. So let's make this rotate around, and we're going to rotate around vector3.up, which is a perfect world up axis. And we're going to rotate by an amount of get axis horizontal, multiply that by 0.1f just to slow it down a bit. Oh, and might spell around correctly, it might help. Okay, so save that. Now if we go back and play, when I'm upright, that's fine, okay, because the y-axis for my character is the same as the world axis. But if I bend down, so let's say I'm taking a bow, and then I go to turn around on the spot, notice my character now rotates like that because it's rotating around that up. And that's not a very natural thing for a character to be doing. So this axis system creates all sorts of interesting problems, and it's even more obvious when you're in a first-person situation, which I'll show you next. So here we are in another scene, and I've got a main camera in the middle, and the code for moving around is actually on the camera this time. The scene also has a cube and a textured ground and a sphere, just so that we can tell that we're moving. Because often if you've just got a plane and it's white and you turn the camera around, it doesn't look like anything's changing. And so you need some point of reference in there. Now on this camera, I've got a cam player controls script, which has some very simple code like we had before. It's rotating using the horizontal axis to turn around the Y, and it's using the up and down arrow keys or the vertical axis to turn around the X, or to bow forward and back. Now let's run this and have a look what happens from the camera's perspective. So we're looking out in the environment and we're turning around and everything looks really good. Okay, so now we're going to use our X-axis and bend forward and back. That looks all right too. But if we're not looking straight up, straight ahead along the horizontal, and then we go to turn around, look what happens because of the way those axes work. So if we come back to like a horizontal horizon, we can then come back down, and when we turn around on the spot, we're not too bad. So the sharper our bow, the worse our turning around our y-axis is going to get. Now that's just using those straight standard rotations around the x and the y. But what if we do a rotate around? So the rotate around, let's do that horizontal again, which was vector 3 dot left. And I'll just multiply that down again, 0.1f. So we're going to rotate around the left axis, which is the horizontal axis, using this vertical amount. Save it and run. Okay, so as expected, our y-axis is fine. If I do a bow, at least I can bow down and come back to where I was. But now if I'm doing bowing, this is bowing. You can see now that what's happening is it's got completely messed up with the axis system. So if you're getting this stuff happening when you're trying to create a character that turns around on the spot, okay, so it bows, looks up and down, and it turns and looks left and right, this is why, because all of the axes of a three-dimensional object, in this case the camera, or whether it's your character, they're all bound together. So if you move one, the others move as well. Right, so I guess the question is, how do we get over this? When we want to turn around and bow down and stand up in a 3D environment, we want the horizontal of the horizon to always stay horizontal in the world, because it's a natural thing for us to, I guess, get a point of reference from. Of course, unless you're creating a flying game, which you'll want these sorts of controls for an aeroplane, because if you're an aeroplane and you move your axes around, this will happen just naturally by the nature that it can move in 3D space. But people, they're on the ground, so we can't actually sort of move freely like a bird or whatever. And even when we do have those sorts of games, we still want that horizon to stay pretty much horizontal. Right, so let's have a look at some other code that can actually fix this problem quite easily. Now I've rewritten the code so that I can turn around on the spot and I can look up and down and notice how nice and horizontal the horizon of the world stays. It doesn't matter which direction I'm facing. When I do a bow, I always come back. I can turn around at this point looking down and keep that horizon nice and flat. So what's happening is that instead of moving just one set of 3D axes, I'm actually moving two so that they don't mess each other up. One set of axes is used to turn around the y-axis, and another set of axes on a completely different game object actually rotates you around the x-axis. And the magic is happening over here in the hierarchy. So I have a parent object that I have made for the camera. The camera moves in one direction only, and the parent of the camera moves in the other direction, which keeps their coordinate systems completely separate. Now, what does that code look like? Just open it up here. So you create the camera. You don't need to create the parent. I'm doing the parent with code. So this code is put onto your camera. When it starts, it's going to create a parent for the camera and then attach the camera to the parent. So the parent of the transform of the camera is equal to the camera's parent transform, and that will basically make it a child. Then what we do is we add our code as before for our two rotations, but this time the one that's going to rotate you around the y-axis is rotating the parent camera, and the one that's rotating you around the x-axis for looking up and down is going to rotate the camera. So it's two separate coordinate systems performing these different operations, which means they don't interact with each other and mess the system up, and everything works just fine. So this is essential knowledge when you start to try and build your own systems for moving your characters around and for rotating them around, and you can see all the complications that happen. You've got to have these two different objects. This is the easiest way, okay? So there'd be a much more complex mathematical way to make sure you keep your horizon flat all the time, but this works really, really well. Now, as I move forward from this tutorial and start to talk about gyroscopic controls and that for your mobile devices, you'll see all of this stuff come into play. Okay, so that's it. I hope you enjoyed this and learnt something. You'll also see if you try out my first person player basic tutorial on how to build one, that also uses a parent and also a child in order to handle both of those rotations. And this is basically the reason that I did it that way. So I'll talk to you next time.